Hello guys, welcome to the Socket Programming 101 tutorial. In this very basic tutorial, I'll teach you the basics of socket programming. I will be assuming that you have not done socket programming at all and that you are an absolute layman to the subject. With this basically as your launchpad, let's move on. So the first question which one has to answer before he starts any topic is why socket programming or why that topic. Now to put it very briefly and concisely, I would say it is to build any networked application in the context of the internet, you require socket programming. Now, a good example is, of course, the Internet Explorer and Firefox browsers, which typically fetch web pages from a web server and display it. This is a very good example of a networked application. Similar are your FTP clients, which go and fetch data from the FTP servers. And last but not the least, and actually the most popular, which is your P2P tools such as LimeWire and BitComet. So in order to understand how these tools actually function, how they communicate, and how data is transferred across the internet between two entities, we need to understand the basics of socket programming. Now the prerequisites for this tutorial. I would just require you to know the basics of IP, TCP and UDP, what they are, how do they differ from each other. For example, TCP is connection oriented and UDP is connectionless, and so on and so forth, and the very basic of C programming and data structures. For this tutorial, we'll be limiting ourselves to compiling on the Linux based system using GCC. Of course, with a little bit of knowledge of WinSock, it is trivial to compile the same programs on a Windows based system. Now, before starting on socket programming or network programming, let's try and hit an analogy. So the analogy which I'll be using here is the telephony network. Now let's look at how a telephony network actually works. Now for a telephone call to initiate, both parties first of all would have to have a telephone installed. Not just that, they require a telephone number which is unique for that telephony network. Say there are two people, Alice and Bob, who each have a telephone installed at their place. Additionally, each of their telephones would have a unique telephone number. So let's say Alice wants to call Bob, then he's going to try and dial Bob's telephone number. Now in order for Bob to be able to receive Alice's call, first of all his ringer has to be on. Now Alice initiates the call by dialing Bob's number. Bob's telephone rings, Bob picks it up, a call is initiated, both parties talk, exchange thoughts and ideas, and once they are done, they hang the telephone. So in short, this is how a telephone call works over a telephony network. Now let's try and dissect this analogy and try to generalize for a network application. How would a network application actually work? So for any network application, immaterial, whether it's a telephony network, a satellite network, mobile network, let's say the internet itself, some things are required. First of all, an endpoint for communication is required on both ends. Second is an address is required, which we saw as in the previous case was a telephone number on both ends to be distinguished, which would distinguish them from the rest of the network. Second, once these two things are in place, one of the endpoints would have to initiate a connection to the other, and the other endpoint would have to be in a ready state in order to receive that connection. Now once this connection is established, both endpoints can exchange data, and once all that data has been exchanged, they close that connection. So bringing this analogy and this dissection to the world of sockets, what do we actually do while programming? So to create that endpoint for communication, as far as network programming is concerned, we use the socket call. Now the unique telephone number or the address which we are talking about, which we would assign to those endpoints, in the world of sockets, bind is used to do that, to give that unique address, which you would see is a combination of an IP address and a port number. Now as we saw that Bob had to wait for Alice's call, and this is actually accomplished by using the listen call. We listen on that endpoint of communication, which is a socket in our socket programming example, for a connection. And now a person who wants to connect to us, let's say another endpoint for communication, uses connect to dial a number. once again the listening process uses accept to receive the call, and then after that, once that connection is established, they use send and receive to exchange data or to talk, as we might say. And finally all the data has been exchanged satisfactorily and things are done, then we use close to basically hang up the connection. Armed with this knowledge, let's now move on to the client server model. Almost all communication in network programming can be fit into the client server model. So actually what is this? So a server can actually be described as any entity which is a provider of information and a client as a seeker of information. An ideal example would be your Apache or IIS server, which is providing web pages. Now this contains a lot of data, and a client like Internet Explorer or Firefox goes and fetches these web pages from the Apache or IIS web server. So now to basically put it, how does this whole model work as far as an operation, real operation is concerned? So now a server has to first start up and wait for a client to connect to it, and after a client successfully connects to it, the client might request for some information. Let's say in the case of our web server web client example, Internet Explorer might ask for the yahoo.com web page from the Yahoo server. The server, if it has the resource or if it has the web page in this case, is going to send back that web page to the client, which is going to display on your screen. Once this is done, the client is going to disconnect from the server, and the server once again starts waiting for more clients. Now let's talk about the TCP server client interaction. In the previous example, it was just a generalized model of how servers and clients interact with each other. Now in this tutorial, we'll concentrate on TCP and UDP. First, let's talk about TCP. So now trying to break up the steps in which we talked about that communication between a server and a client. Now as you can clearly see here, the server first calls the socket, which is going to create the endpoint of communication. The client also does the same by calling socket. The server then calls bind to basically attach a unique address, in which case is an IP address and a port number to which it is going to be listening for various clients. Then the server goes on to what is called the accept stage, in which it waits for a client to connect to it. At that point we can see that a client will use the connect call to establish a connection with the server. Now we'll go into what arguments all these calls take a little later, but let's just talk at a very high level what is happening first in order to increase one's understanding. So fine, once the client call connects and a connection has been established with the server, both of them can call read and writes to basically transfer data among each other. Once all the data has been transferred, they call close to basically close the connection.